questions 11 through 20 on the 2007 Grade 10 AMC 10A. The numbers from 1 to 8 are placed at the vertices of a cube in such a manner that the sum of the four numbers on each face is the same. What is this common sum? We have a cube, and I'll just label the vertices A, B, C, D, E, F, G. And the numbers 1 through 8 have to be placed in such a way so that if you add up the four numbers on each face, that sum will be the same. So for example, this face right here is A, B, C, and D. So A plus B plus C plus D, that is a sum, and all the sums are the same. Now if I look at that face, that sum is E plus F plus G plus H, correct? Now all the sums are the same, and that's why I am able to set it equal to each other. Okay? Now we also know that all of these numbers, A plus B plus C, all the way till H, if you add them all up, that sum is very easy to figure out. Why? Because that sum is basically all the numbers. Regardless of order, it's going to be 1 plus 2 plus 3 all the way until 8. Correct? So what is 1 plus 2 all the way to 8? Well, 8 times 9 divided by 2, and that is 4 times 9, 36. So all of these added together equal 36. Well, we know that this is equal to this. So these four are really equal to A plus B plus C plus D. So essentially what you have is 2 times A plus B plus C plus D is equal to 36, and therefore A plus B plus C plus D is equal to 18. So the sum is 18, and that's the common sum when you do this type of system for any face. So number 11, the answer is 18, which is choice C. Two tour guides are leading 6 tourists. The guides decide to split up. Each tourist must choose one of the guides, but the stipulation that each guide must take at least one tourist. How many different groupings of guides and tourists are possible? So we have possibilities as follows. We can have one guide with one tourist, like that. We can have one guide with 2 tourists, one guide with 3 tourists, and one guide with 4 tourists, and finally one guide with 5 tourists. You cannot have one guide with 6 tourists, because if you did, the other guide would have 0, and that is not allowed because each guide must take at least one tourist. So for each of these, we got to figure out how many cases. Okay, the one guide part, there's 2 guides, so we have 2 possible choices for the guides. But for the tourists, there's 6 possible choices. So 2 times 6 is 12. That's how many scenarios there are for one guide and one tourist. Next one, for one guide, it's again 2, but for 2 tourists, basically you have to choose 2 tourists from 6. So it's 6 choose 2, like that. And that becomes 2 times 6 choose 2 is equal to 15. So this is 30. All right, next one, again, same kind of story for the guides, but now it's 6 choose 3, and 2 times 6 choose 3 is 2 times 20, and that is 40. Then one guide and 4 tourists, again, 2 choices for the guides, but from this, it's 6 choose 4, that is going to be 2 times 15, so that's 30. And finally, one guard and 5 tourists, 2 choices for the guides, whatever they are, and then for the tourists it's from 6 choose 5, and that's going to be 2 times 6, which is 12. So we have to add all these up, and when you do, you get 124. But this double counts. Why does it double count? Well, let me explain. For example, if you have this guy right here, 1G and 1T, let's say that G, that guide, is the first guide. So it's guide number 1. And the tourist, any of the tourists, it's tourist number 1. That means in that scenario, the other matching scenario would be the guide 2 with the other 5 tourists, tourist 2, 3, 4, 5, and 6, correct? But that scenario is already included down here. It would be one of these guys. So for each of these, we basically have double counted. So we have to just divide the 124 by 2 to get the number of unique scenarios, and that would be 62. So number 12, the answer is D. Yan is somewhere between his home and the stadium. To get to the stadium, he can walk directly to the stadium, or he can walk home and then ride his bicycle to the stadium. He rides 7 times as fast as he walks, and both choices require the same amount of time. What is the ratio of Yan's distance from his home to his distance from the stadium? So this is his home, this is the stadium, and I don't know where he is, but let's say Yan is approximately here. And the distance from his current point to the stadium, I will call N, this distance right here, and the distance from his current point to his home, I will call M. And what the question is asking is the ratio of the distance from his home to his distance from the stadium. So what they're asking for is really find M over N in terms of my notation. So here we go. We're going to be using this formula, speed is equal to distance over time, and a slight rearrangement of that formula, which is time is equal to distance over speed. Now they tell us that for both scenarios, the time is equal. So I'll call this time 1 and time 2. So what is the first scenario, time 1? It's basically him going from his current point to the stadium, but walking. Okay, no problem. So that would be, if you were to look at T1, D1 over S1. And similarly for T2, he's going back home walking, but he's going to then get on his bike and ride the bike all the way to the stadium. So there's 2 components there. There's the first time that goes from there to there, and then there's the second time, which is going from there to there. So it's kind of like T2 has sort of 2 components, right? So the first one is going to be, I'll just call it D2 over S2, and then we'll call the next one D3 over S3. So let's figure this out. D1 is what? This distance right here, right? So that's just N. And then S1 is the speed, and the speed is basically him walking. So I don't know what the speed is, so I'm just going to denote that as S for speed. Now let's talk about the next scenario. D2 is this distance right here. So that's M. And that speed, well, is he walking or riding his bike? He's walking. So that's again just S. Now we have D3 all the way from home to stadium. So that distance is M plus N. And then this speed, he's riding his bike. So that S3 is the speed on which he travels when he's riding the bike, and that's 7 times as fast as he walks. So it's 7S. So this is the mathematical equation that hopefully will give us M over N. Well, let's get a common denominator, multiply everything top and bottom by 7. And if you do that, you get 7n over 7s is equal to 7m over 7s plus m plus n all over 7s. Now the 7s's can all disappear, and we can just concentrate on the numerators. So 7n is equal to 7m plus m plus n. And this gives me 6n is equal to 8m, and therefore m over n is going to be 6 over 8, which is 3 over 4. and that is what they wanted us to figure out. So the answer to number 13 is B. A triangle with the side lengths in the ratio 3, 4, 5 is inscribed in a circle of radius 3. What is the area of the triangle? So first we have a circle, and then we've got this triangle, and it has a certain side ratio, 3, 4, 5. Now, 3, 4, 5 is the ratio, so I'll just call it 3x, 4x, and 5x, because that is just the ratio. It does not mean that those are the lengths of the sides. Now, immediately I notice this is a 3, 4, 5 triangle, right? You all remember that is a Pythagorean relationship, because 3x squared plus 4x squared is equal to 5x squared. So if it is a Pythagorean relationship, that means this is a right angle. So that definitely helps, right? So what do we know? We know that the circle has a radius of 3. So one thing is that if you have a triangle and you draw it inside the circle so that the vertices of the triangle touch the edges of the circle, and that angle is 90 degrees, what that means is that this is the diameter. That is the rule. So that basically means that 5x is equal to the diameter of the circle, and the diameter is equal to 2 times the radius. So 5x is equal to 2 times 3, because they tell you that the radius is 3. So that means x is equal to 6 over 5. Now what do they want? They want the area of the triangle. The area of a triangle is 1/2 base times height. The base, we can call this the base, 3x. And the height, we can call this the height. So that's 4x. So this basically becomes, let's see, 12 over 2, 6x squared. And then that would be 6 over 5 all squared. So this looks like, well, I think you can do this in terms of a fraction or in terms of decimals, right? I look at the answer choices and I see some decimals in there. So it could, because this is essentially 6 times 36 over 25. And if you do the decimal format, it will be 8.64. And that looks like 14 is A. 4 circles of radius 1 are each tangent to 2 sides of a square and externally tangent to a circle of radius 2, as shown. What is the area of the square? In this diagram, we will draw some lines. The first thing is a line directly from the corner to the center of the big circle in the middle. And I think that should be good enough, but I'll draw one more line from the center to meet the side so that it's perpendicular like that, so making that a right angle. And yeah, I think that should be good enough. So let's work with this. Now, one more scenario I think we will need, and that is a square up here, like that. Okay, so this should be sufficient. Let's label things now. From here to here, that is just the radius of the large circle, so that's going to be 2. From here to here, that's the radius of the small circle, so that's 1. And from here to here, we don't know yet, so I'm just going to label that x. Now, from here to here, we do know that is the same as that, which is the radius of the circle, so that's 1. And we also know that from here to here is the same as the radius of the circle, so that's also 1. This is 1, this is 1. They're all radii. So the very first relationship is this one right here, this small triangle. That small triangle I will draw over here. And that one is going to give me my value for x. This is 1, this is 1. So 1 squared plus 1 squared is x squared. So that means 2 is equal to x squared. So x is root 2. All right, so that's the first one. Now, the next relationship involves this full line right here. That full line we can figure out it's going to be just x plus 1 plus 2 from here all the way till here. And that looks like it is root 2 plus 3. Correct? But I'm actually more interested in the full diagonal. So I want to go all the way to the edge like that. Well, that full diagonal will just be double that, right? Because this is half the diagonal. So the full diagonal will be 2 root 2 plus 6. So I'll just write D for diagonal. So that's a very important finding in this question. Now we are interested in finding the length of the side, because eventually the question wants us to figure out the area of the square, correct? So we have to figure out the length of the side of the square. So the length of the side of the square, whatever you want to call it, we can call it y, like that. And we use this big triangle to figure out y. And here we go. So y squared plus y squared is equal to the diagonal squared. So this means 2y squared is equal to the diagonal squared, which is 2 root 2 plus 6, all squared. All right? And therefore, if I isolate for y squared, I'll get 2 root 2 plus 6 squared over 2. Now the question asks me to figure out the area of the square. The area of the square is just y squared. And this is y squared. So I'm pretty much done. The only thing is, this is my answer, but I have to get it into one of these forms. And this is a common situation on math contests where you'll get the correct answer, but it's not in the same form. The numerical value is going to be identical, but we have to make it look like one of these. All right, no problem. I think I can do that. Let me just use this space here. So y squared is going to be, I have to square this, so 2 root 2 squared is going to be 8. And then 1224 root 2, and then 6 times 6, 36. And then that's all over 2. So this looks like 44 plus 24 root 2 all over 2. And that looks like 22 plus 12 root 2. 22 plus 12 root 2, which one of those answers? That is B. So number 15, the answer is here. Integers a, b, c, and d, not necessarily distinct, are chosen independently and at random from 0 to 2007 inclusive. What is the probability that AD minus BC is even? AD minus BC, and we want this to be even. All right, so we've got to look at a few scenarios here. We have two numbers that when subtracted give you an even result. And how does that work? How does that happen? Well, let's look at the possible choices or possible scenarios. If the first guy is even and the second guy is even, this BC, and I subtract them, what is my result? Well, my result, even minus even, is even. What about if I have even and odd? If AD was even and BC was odd? Even minus odd is odd. How about if I have odd and even? Like that, where AD is odd and BC is even. Well, that's odd. And finally, I think odd is what's left, right? So AD is odd and BC is odd. Odd minus odd is even. Okay, so far so good. So where do I proceed from here? Well, first and foremost, which one am I interested in? I'm interested only in this guy and this guy, because these ones don't give me what I want. I want even. So I'm going to look at this. So far we're moving in the right direction. Now we need to talk about even for AD and even for BC. Okay? So I'll make a little comparison table here. A times D, and what is the result? If A is even and D is even. See what I'm doing here? Now I'm looking at what happens when you multiply. What is the result? Even times even. Well, it's even. How about A is even, but D is odd? What's the result? Well, that's even again. What about if I have odd for A and even for D? The multiplication results in an even number. And finally, if they're both odd, the multiplication will be odd. So here we go. For this guy right here, even for AD, what's the probability of getting an even for AD? Well, look over here. Even. Out of the 4 possible ways, it happens 3 times. So the probability is 3 over 4 for this, for AD to be even. Now I've got to look at this guy, even for BC. Well, the same story. If this was B and C, it really doesn't matter. If they are in this scenario, or this scenario, they're going to be even when you multiply them, B and C. So again, the probability is 3 over 4. So both of these have to be even. So 3 over 4 times 3 over 4, that's how you get the probability of that scenario, which is 9 over 16. Okay? Now I turn my attention to this guy. If it's odd for what? AD, right? How do I get odd for AD? Well, it's this scenario here. AD will be odd if A is odd and D is odd, and that happens 1 out of 4 times. So 1 out of 4. And again, now I want odd for BC. Well, BC will be odd, exactly the same probability, 1 out of 4. And I have to multiply those, so I get 1 out of 16. So now to get the total probability, I have to add this guy and this guy. So that's going to be 9 over 16 plus 1 over 16, and that is 10 over 16. In lowest terms, that's 5 over 8. So 5 over 8 for number 16 is E. Suppose that m and n are positive integers such that 75m is equal to n to the power of 3. What is the minimum possible value of m plus n? 75 times m is equal to n to the power of 3. So first, let's break up 75 into its prime factors. 3 times 5 times 5. And we got this m, and this is n to the power of 3. Now, m and n are both positive integers. So this whole thing must be a cube, right? That's the only way. If you take the cube root, it's going to be equal to n, which is an integer. So this has to be a perfect cube. I guess that's the term. So how do I do that? In a way to make m as small as possible. Well, think about it for a second. I've got 3 times 5 times 5, and then I've got something else. We don't know. Well, that something else is represented by m. If I put another 5 in there, then this will be 5 to the power of 3. And that's great. That makes it a perfect cube. That's exactly what I want. All right, so I think m is going to have that 5 in there. But I still got this 3 left over. But what if I added 3 and 3 like this? Then this 3 plus these 2 3's become 3 to the power of 3, correct? And that again fits perfectly with what I have. And that's exactly what m is. M is equal to 5 times 3 times 3, which is 45. All right? So if we put 45 in there, this now becomes, this guy, it becomes 3 to the power of 3 times 5 to the power of 3, which is n to the power of 3. So that means n is equal to 3 times 5. which is 15. So they want m plus n. So m plus n, m is 45, n is 15, and that equals 60. So number 17, the answer is D. Consider the 12-sided polygon A through L as shown. Each of its sides has length 4, and each two consecutive sides form a right angle. Suppose that AG and CH meet at M. What is the area of quadrilateral ABCM? So they want you to figure out the area of ABCM, this shape right there. Several ways of doing this question. What I'm going to do is I'm going to put everything on an coordinate axes. And at first that might seem like a bit extreme, but it's actually not. It's pretty quick. Not as long as you'd think. All right, but I'm going to do it slow so it won't be as quick because I have to make you understand it. All right, so what I'm going to do is I'm going to put it on the coordinate axis in a way so that it looks like this, basically. Like that. See what I mean? And I'm only concentrating on this rectangle. I don't care about anything else. It's pointless, meaningless to me. So just that rectangle. Okay? And that rectangle, in terms of the coordinates, were A, B, G down here, and H. All right? And then I'm going to, of course, have to draw these sort of lines, I guess, to illustrate that we've got a certain length that matches up. And that's going to be C, and I've got to draw a line from C to H like this. And one final line from A to G. Okay? So this is C, and this is M right here. So there you go. I'm done with the labeling. Now I've got to figure out the equation of these two lines, this one and this one. And once I figure out the equation of those two lines, I can find what M is. It's the intersection point. So here we go. Let's label these. H is the origin. G, remember, all the sides are 4. So G is essentially 4, 0, like that. This C is 4 across and 4 up. 8 up, so it's 4, 8. And A is going to be 0, 12, like that. And that's it. So here we go. Let's first, doesn't really matter what order, but let's look at this line first. So y equals mx plus b. One point is 0, 0. So immediately we got b is equal to 0. So that means it's y equal to mx. Put the other point 4, 8, and that's going to give you 8 is equal to m times 4. So that means m is 2. So the equation is y is equal to 2x. So that's this one. Y is equal to 2x. All right. In a very similar way, let's figure out the equation of this line. So y is equal to mx plus b. If I substitute this coordinate 0, 12, I get 12 is equal to b very quickly. And then I'll substitute that to get m. So that means 0 is equal to 4m plus 12. So that means m is equal to minus 3. So that equation is y is equal to minus 3x plus 12. Minus 3x plus 12. All right. So far, so good. Nothing complicated. Now I have to find m. How do I find m? Well, it's the intersection of those two lines. So that's going to be 2x is equal to minus 3x plus 12. So that means 5x is equal to 12, and therefore x is equal to 12 over 5. And that's what, about 2.4? You don't have to convert it to decimals, but for some reason it makes it easier for me. And y, well, y is equal to 2x, so y is going to be 4.8. That's the coordinates for m. So m is 2.4 and 4.8. Now we finally get to the point where we can calculate the area. And what do we want? We want ABCM. So we want ABCM, that shape. So here we go. ABCM is going to be equal to, first it's going to be that full triangle, sorry, the full rectangle, ABGH, right? And then we have to subtract from it 3 triangles. We have to subtract CMG, right? This triangle. We have to then subtract this triangle, which is HMG. And finally, we have to subtract this triangle, which is AMH. All right, here we go. ABGH is just length times width, so that's going to be 4 times 12. Correct? Minus CMG, 1/2 base times height. CMG, the base is going to be 8, and the height is going to be from there to there. Well, M has an x-coordinate of 2.4. What that means is that from here to here is 2.4. So this guy is going to be 4 minus 2.4, which is 1.6. So we got 1.6 in there. Minus, we've got HMG. HMG, 1/2 base is 4. And the height, well, the height is the y-coordinate of M, so 4.8. And finally, AMH, 1/2 base times height. The base is 12 all the way from top to bottom, and the height is the x-coordinate of M, which is 2.4. And that's it. We're done. We just have to do the math here. So this looks like 48 minus 6.4 minus 9.6 minus 14.4, and that is 17.6. 17.6, and they've got it in fractions, but if you were to figure out each of these fractions, 17.6 is equal to 88/5. So number 18, the answer is C. A paintbrush is swept along both diagonals of a square to produce the symmetric painted area. As shown, half of the area of the square is painted. What is the ratio of the side length of the square to the brush width? Let's do a little bit of labeling. I don't think we'll need to label that much, but this distance right here, from there to there, that distance is very important because that distance basically represents the question answer. The brush width. That red line is the brush width. And I'm going to draw that over there, over here, like that, to illustrate that those 4 are equal triangles. And I'm going to label that. We'll call it just Y. Okay? So we basically have to find Y, but we have to find a ratio of the side length. So here's the side length of the square. Let's call that X. So that's X, and this is X. So we have to find X over Y. All right? So X over Y is my requirement. And to get that, I'm going to have to do a little bit of algebra here. So the very first thing is I'm going to label this guy right here, from here to here, A, this distance. And very similarly, that is also going to be A, that tiny little distance. And that will help me figure out a relationship between A and Y. So first, we can do that up here, I guess. A squared plus A squared is equal to Y squared, right? Because if this is Y, this is Y. It's just that width. So I'll just label that there. So this first relationship gives me 2A squared is equal to Y squared. And therefore, taking the square root, you get 2A is equal to Y. And therefore, A is equal to Y over root 2. Now, in a very similar way, I'd like to get a little bit more. I'd like to get this length. somehow, some way. So I'm going to label that W. And because of the symmetry of this diagram, that's also W from there to there. All right? And this is again a right angle. So that will give me a relationship between W and X. But this is a little bit trickier. W squared plus W squared is not equal to X squared because X is all the way across. It's only equal to this. And that is X minus 2A. Correct? You got to subtract A from there and A from there. So that is the correct relationship, all squared. Don't forget to square it. So this becomes 2W squared is equal to X minus, but A we just figured out in terms of Y. So it'll be 2Y over root 2 all squared. And if I take the square root of everything, it'll be root 2W is equal to X minus 2 divided by root 2 is just root 2, like that. And then this can be further simplified. W is equal to X over root 2 minus Y. All right, so there's my first one, and there's my second one. And eventually, hopefully, we will be able to figure out that. Okay, so far so good. Now, we have to use some important information that they gave us. Half of the area of the square is painted. That's very important. So what that means is that the area of the shaded region, which is representing the painted area, that represents half of the square. So the area of the shaded region is X squared divided by 2, right? The area of the square is X squared, and the area of the shaded region is half of that. That's essentially what this sentence means. So we work with that. What is the area of the shaded region? Well, I've already broken the diagram into the appropriate segments. I think I have to just do that to kind of illustrate it completely. It's going to be first and foremost 4 of these little guys. Area of the shaded region. Right? So 4 times 1/2 base times height. The base is A, but instead of A, I'm going to put it in terms of Y. Y over root 2. Base times height, which also is A, which is Y over root 2. Okay, that takes care of the small triangles. Now we have to add 4 of these rectangles, correct? That one, this one, and this one. So 4 of those guys. So again, 4 length times width, Y, and then W. But instead of W, I'm going to put this, because I want everything in terms of X and Y. X over root 2 minus Y. And then finally, I've got to add this square in the middle. And that's just Y squared. Correct? And that is equal to X squared over 2. This right here. So this is the equation that's going to help us solve for X over Y. It won't be extremely straightforward, but we'll do a little bit of fanciness. All right, so let's work with this without making any mistakes. So we've got, let's see here, 4 divided by 2, 2y squared over 2. Okay, this one, 4xy over root 2. And then 4y squared plus y squared is equal to x over 2. X squared over 2. Let's see, what can we do here to simplify? Well, this is just y squared, and then minus 4y squared. So that looks like 2y squared minus 4y squared. So that's minus 2y squared. And then this, if you rationalize the denominator, would be 4 root 2 over 2, which is 2 root 2. So 2 root 2 xy. And this is x squared over 2. All right, let's see, what can I do here? Multiply through by 2, get rid of that fraction. 4 root 2 xy minus 4y squared is equal to x squared. Okay, at this point, what do I do? How do I isolate for x and y? Remember, my goal is to figure out x over y, just the ratio. I don't necessarily need to find the individual values. what do I do here? Well, I'm going to put it all on one side, see if that helps me. X squared minus 4 root 2 xy plus 4y squared. Now, I think I just said about 10 seconds ago that you don't really need to worry about figuring out x and y, because in the end, you're just going to need a ratio. So because we only need a ratio, I can sort of choose whatever I want, correct? So let me set y equal to 1. And if I do that and I solve for x, then x over y should work because we just want a ratio. We don't have to get an exact value that they want us to get for y or x. And the fact that they only want a ratio is the only reason I can do this. All right, let's see what happens. If y is 1, we get 4 root 2x plus 4. Yeah, that's it. All right, great. I can use Pythagoras. Or sorry, not Pythagoras. I can use the quadratic equation. All right. So here we go. Minus b plus or minus square root of b squared minus 4ac. Correct? All over 2a. So this gives me 4 root 2 plus or minus 4 root 2 squared is 16 times 2, 32. 32 minus 16 all over 2. And that makes me get 4 root 2 plus or minus 32 minus 16 is 16. Root of that is 4. All right, great. So that means this is 2 root 2 plus or minus 2. Okay, I got two values. Oh boy. Well, I had let x equal to 1, right? So that means x must be 2 root 2 plus 2. Because if it was the minus guy, 2 root 2 is approximately 2.8. 2.8 minus 2 would be 0.8. And x cannot be 0.8 because x has to be greater than y. If you look at the diagram again, x is obviously greater than y. So great, I got it. I got my x value, got my y value, and they want, what did they want? X over y, correct? Okay, well, x over y is 2 root 2 plus 2 over 1. That's it, 2 root 2 plus 2. So that would be, for number 19, choice C. Suppose that the number a satisfies the equation 4 is equal to a plus a to the negative 1. What is the value of a to the 4th plus a to the negative 4? This question has several approaches. There's the short way, there's the long way, there's all kinds of ways. Maybe as 6 different ways of approaching this. You can use trigonometry. You can use quite a few things, but the way I did it is sort of the standard way. It's sort of in the middle. It's not the shortest way and it's not the longest way. So I'll just show you that. But I just want you to know that whatever system you have is fine. And as always on a math contest, try for the shortest, quickest way of doing it. So here we go. This is how I did it. First and foremost, let's just look at this guy right here, right? So that's 4 is equal to a plus a minus a to the minus 1. And that is a plus 1 over a. Correct? So I obviously eventually have to get powers of 4. So first let's get powers of 2. Let's see what happens. So I get that by squaring both sides. If I square both sides, that will be a plus 1 over a all squared. So this is 16 is equal to a squared plus a over a, which is 1 plus 1, 2 plus 1 over a squared. Correct? So this looks like 14 is equal to a squared plus 1 over a squared. All right. I've got squares. In order to get powers of 4, I probably have to square again. So here we go. Let's square this again. 14 squared is going to be 196. A is equal to, and then I've got to square this guy right here. So essentially what I did was I just squared this and squared that. So a to the 4th plus a squared over a squared again is 1, and then I do that again, so I get 2, and 1 over a to the 4th. So if you subtract that, this gives me 194 is equal to a to the 4th plus 1 over a to the 4th. And that's exactly what this is. So there you go, 194. And like I said, there's a long way, there's a short way, there's a trigonometry way, there's another one using eliminating certain choices, because this is basically a perfect square minus 2, and there's only one choice like that. But regardless, the system or method that I would recommend is the one that requires the least amount of time. And I think this is pretty short for a question as advanced as number 20. So number 20, the answer is D.